It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farmers Union Nice Coffee.
3, 2, 1. Hi guys, hopefully before watching this video you've actually watched the video on acids because this is a really good follow-on. There'll be a couple of things which I'll refer to in this video that you should hopefully know from the previous one. So if you haven't watched the one on acids, just hit pause, don't worry, I won't be offended, and go back and watch the one on acids first. All right. What we're going to be looking at is bases, and in particular what we're going to be doing is talking about just the different types of bases you can have and what they do in terms of indicators. Okay, so just like for acids we had two types, with bases we kind of have two types as well. Okay, and if we're talking about a water insoluble base, that's just called a base. But sometimes what you'll also hear talked about are water soluble bases. And water soluble bases we call alkalis. Okay, so you might have heard this referred to on the periodic table if you're looking at group 1, which are the alkali metals. So sodium as it starts through there in that group. Then you've got group 2 with magnesium, they're the alkaline earth metals. Okay, so that all relates back to the fact around that those oxides of those metals are basic. Okay, and so if it's water soluble, we call it an alkali. If it's insoluble, we call it a base. The most common base that you probably ever come across is something like sodium hydroxide. Okay, so NaOH. And this comes around by the fact of when you take one of the alkali metals of sodium and you dissolve it in water, okay, you will end up, in fact, with sodium hydroxide. Okay. You also get some hydrogen gas, so it will fizz around quite a bit, so plus H2, okay? And you can balance up that equation later if you want. I'm not going to bother doing that now. All right, so taking an alkali metal, dissolving it in water, and you get your base over here. In this case, a water-soluble base, which is sodium hydroxide, okay? Now, bases, just like acids, can be concentrated or dilute, okay? They can be strong or weak as well. And that just comes down to, again, their ability to ionize in water. So I'm not going to go through all that again. Hopefully that got covered in the acids one and you picked up on that. Okay, just letting you know though that can be exactly the same. We do get some color changes for bases in indicators, and some of the most common ones again we use are universal indicator. When we're using universal indicator with a base, you get the colder colors. So you get your blues and your purples, okay, and that's your pHs of around 8 to 14. You can also use methyl orange, which is another one we said. Methyl orange in a base goes yellow. Okay, you can use phenolphthalein as well, probably my favorite indicator to use, because when you put it in a base, it goes this beautiful magenta color. Now magenta is like a purpley pink color, very, very clear that you can see that. Okay, other one you can use often is litmus as well, and litmus goes generally blue in the presence of a base. Okay, so just like acids, you can determine the concentration of them, okay, and you can use an equation to calculate the concentration of the hydroxide ions or what the pH will be. So again, there is a video on this. Okay, so just like in the acids, where we defined an acid using the Lowry-Bronsted theory, where we said an acid is a proton donor, a base, therefore, as it follows, you would expect that would be a proton acceptor. Okay, and so what that means is that when it reacts with an acid, okay, it will actually take that hydrogen, that proton, from the acid. So a really good example of that to show, that shows both of them, is if you take, for example, hydrochloric acid, okay, and you react that with a very, very common base, sodium hydroxide, okay. So here we've got hydrogen, the proton, that is going to be donated from the acid. Now what happens is that proton is donated over to the base, which is the hydroxide, okay. And what happens is that we end up with sodium chloride, so a salt being formed. And the base over here, the hydroxide, that accepts the proton. If you've got an oxygen and a hydrogen, you accept one more hydrogen, you end up with 2 hydrogens and an oxygen, which is how we get water. Okay, so A base is a proton acceptor, an acid is a proton donor, and that's really one of the keys around bases that you need to know. And so the equations that you want to use if you're doing POH, okay, so using a base this time, so POH is negative log concentration of your hydroxide ions. However, you might not always have the concentration of your hydroxide ions, or you might not know the POH. So there is a relationship that links these as well. So your POH plus your pH is equal to 14. So if you know that your pH is 11.8, you can take that away from 14 and get your POH, all right? You can also use the concentration of your hydroxide ions times by the concentration of your H plus ions. And so that looks like this: concentration of hydroxide ions times by the concentration of the H plus ions. That is equal to 10 to the negative 14. So if you're pretty good at maths, you can rearrange that to get your concentration of hydroxide ions, plug that in and get your POH, and then use that with this equation here to get your pH. Again, that's covered in the acid, rain and pH adjusted video. So I suggest if you want some more help with those calculations, you go back and have a look at that. All right, so this one's a reasonably brief one. As I said, just wanted to go through bases. So there's two types. If they're water insoluble, it's called a base. Water soluble is an alkali. Okay, so hopefully this has been helpful for you. And as always, if you've got any questions, just ask. Thanks, guys.